Right, let's look at some examples, and as always it's really important for these things that you pause the video if necessary and check your understanding before you carry on and listen to me tell you what the answer is. The question, as usual, is what does this code print? What's going to happen? We've got a main function, we set up an array with 0 and 1 in it. We call our add1 function. We're going to do this quite a number of times in different variants. In this case, our add1 function takes an integer array called an array and it increments the 0th index into that array. And then we print out the resulting elements of the array back in the main function. Now, what's this going to print? It's going to print 1, 1 due to call by reference and side effects. So we passed the array reference A into the add1 function, and because only the reference was copied and the two things were actually references to the very same array on the heap, the incrementation that was done in the add1 function was indeed able to side effect the array as seen from the main function. Now what about this variation? So here we've got the main function just as before, but this time the body of add1 has changed. Add1 now has the body, it's going to set an array to be a new integer array of size 2. What does this do? Well, in this case, that makes no change to the array. So this prints 0, 1, just like the initial values of the array, because what happens in add1 this time is that a new array is allocated, no change is made to the array that was passed in. What about this variant? This one is the same, but this time we're going to return the array from add1. And the other difference that I should have remarked on is the fact that we also are going to make the return value from add1 be the new value of the array variable A inside main. And that's the crucial thing here, because what's happening is that in add1, an array which is subsequently returned is a new array automatically initialized with 0 values, and then in main we make that be the array that the array variable A points at, and then that's what we print out. Now, side effects can be dangerous, and in fact if you thoroughly absorbed the lessons of Haskell programming in Inf 1A, you might already be indoctrinated into this idea. And you can avoid those dangers of side effects by using immutable objects. All we mean by an immutable object is one that cannot change its state after it's been created, and string and integer in Java are examples of these. Circle and char, that we've been playing with just now, are examples of mutable objects. You can indeed change their state after they've been created, and indeed that's kind of the point of how you want to use them. So there are pluses and minuses to both mutable and immutable objects. It's not that one is right and the other is wrong. They have different pros and cons. It is very important to know which you're dealing with. One of the things immutability does is to allow stuff like interning, which we talked about a bit before, and of course copying the object by simply copying the references, because if you know that the state of the object can't have changed, then life becomes a lot easier. So now we've covered a bunch of this stuff, and we've now newly talked about the fact that objects reside on the heap rather than on the stack. One thing you might have wondered about is, well, what happens in a situation like this example, where a method that we call, in this case add1, allocates some new memory, it creates a new array object of a particular size, but then nothing is done about it. So in this case the add1 function has a void return type, so there's no way that anything outside that function can actually refer to that new memory that we just allocated and pointed an array at. So what happens to it? Well, it needs to get cleaned up, and this is called garbage collection. So if you end up with an object on the heap that is no longer referenced by anyone, by anywhere in the code, at that point the Java Virtual Machine's garbage collection takes place and reclaims that memory for future use by the program. And that's really important, because if it didn't do that, then the add1 function would leak memory every time it's called, until eventually we would actually run out of heap space. Next, objects can contain other objects in a certain manner of speaking. So one of the things we can do is we've talked about arrays and we've talked about objects, but I think we haven't yet talked about arrays of objects. Okay, so here we have an array of circles. It's going to be called sum circles, and it's going to be an array that contains space enough for 5 circles. And so you should think about it as looking a bit like this. We have the sum circles variable on the stack, and it is going to point at an array on the heap with 5 entries, because it's an array of 5 circles. And remember that we said that arrays are automatically initialized with an appropriate 0 value. Well, for objects, the appropriate 0 value is null. Okay, so each of these new circles starts off being null. Now, a null object is not terribly useful. In order to do anything with it, we need to instead have each of those entries pointing at an actual object, and each of those things has to have space allocated explicitly to it. So let's see what we mean. So suppose what we now do is we say index 2 of the sum circles array is now going to be assigned the new value, which is going to be a new circle with radius 10. Then what happens is we now have a new object also living on the heap with radius 10, and instead of null in that array position, we now have a reference to that new object. Here's another example. We can have on the stack 2 variables, offender and truck, of type car and tow truck respectively, and they point at different objects, and we can set it up like this. And the new and interesting point here is the idea that when you create an object of class tow truck, you pass it an argument of type car in this case, and judging from the picture, that's going to be stored in the instance variable cargo of the tow truck object, in the sense that the value of that piece of data inside the tow truck object is going to be a reference to another object, in this case a reference to the car which is currently being towed by the tow truck. And so it goes on. You have to be a bit careful with shallow copying and deep copying. I said before that you had seen this before, maybe you hadn't in fact. Right, so what is there to say about this? Let's have a look at the code. So there are some things we can do. We can set ourselves up with an array of 5 circles as before, and we can fill in each element of that array, in each case by creating a new circle of a particular radius. In this case what we're doing is we are creating each circle with a different radius by passing as its radius the current loop variable times 10. So here we've got an array of circles of different size. That's the point there really. Now we can do a shallow copy, which is to say we could create ourselves a new array of circles, and then we could say we're just going to say we want a copy of each of those references to objects in our new array entry. Or we can do a deep copy, which is to say again we're going to create a new array of circles, but now what we're going to do is we're going to have in each place in our array a reference to a new object which has the same radius as the corresponding object in the array that we're copying. You might need to pause this and have a think about it. But it's a question of whether what we have now is 2 arrays which both contain references to the same set of circle objects, or whether we have 2 arrays which contain references to 2 different sets of circle objects that simply correspond in pairs because each one has been created with the same radius as the corresponding one in the other set. So what have we added? We have added now that objects get destroyed automatically by the garbage collector if we're in a position where they can't be referenced anymore. And in summary of this whole section, the Java virtual machine manages memory in two different areas, in the stack and in the heap. This has a number of implications. It means that you have to watch out with recursion that things don't go too deep, and you have to think about function side effects. You know already that an object variable that contains null references no memory. That's what we mean by containing null. We talked about stack frames, which get cleaned up once the function scope is left, and we talked about garbage collection, which cleans up the heap. So we have two different ways of cleaning up the different kinds of memory. You know that immutable objects can't change their state once initialized. That's what immutable means. And you saw an example, which you might want to come back to the first time you actually run into this issue in real life, comparing deep copy and shallow copy. The reading, the Java tutorial, as before, you are very welcome to read up to the end of chapter 4. You will find that because it does things in a slightly different order from this course, you will encounter some new material. If you find yourself at all confused about the difference between stack and heap and how they work, you might find that blog article a helpful adjunct. It goes through things quite carefully and is quite nicely written.